Hello everyone, we are going to practice graphing, identifying slope, identifying the y-intercept. We're going to go through everything as far as the slope-intercept form of a line. Let's get right to it. Algebra 1, here we go, graphing practice. The measure of the steepness of a line is called the slope. And obviously, we're going to put that right there. If the line goes up from left to right, the slope of the line up from left to right is positive. It's a positive slope if it goes up from left to right. If it goes down from left to right, it is negative. It's a negative slope. Which line has a steeper slope? A line with a slope of 6, a line with a slope of -4. And it says justify. The line with a slope of -6 is a steeper slope. Doesn't matter if it's positive or negative. 6 is steeper than 4 because it is further away from 0. Okay, the steeper slope is 6, and the further a slope is away from 0, the steeper the line. A linear function that goes through the origin, is called a direct variation, and it is also known as a proportional relationship. Okay, when you are graphing a line, remember, always identify the slope in rise over run format. Just put a 1 underneath. If it's a whole number, you could just put a 1 underneath the coefficient right before the x. That is the rise over run. The other number with the sign in front of it is the y-intercept. It's where it crosses the y-axis. So I'm going to draw a line that goes down the entire y-axis just like that. And I'm also going to make sure that I use my directional arrows. This is the rise, this is the run. All right, 2 is the rise. If it's positive, it goes up from up. And if the run, if it's positive, it goes right. So I'm going to talk about -3 as the y-intercept. The -3 is right there. Remember, the y-intercept could be 0, -3. That is the coordinate. When x is 0, the other number is the y-intercept. So the y-intercept being -3 is right there. That's the first point that you're going to put on the graph. Then you're going to rise 2. You're going to follow your slope. You're going to rise 2 and run to the right 1. Rise 2 again, run to the right 1. Rise 2, right 1. Rise 2, right 1. You could go a little bit faster. Rise 2, right 1, and rise 2, right 1. You stop right there. Then you have to go ahead and put some points on this part of the graph. Instead of going up 2, you're going to go down 2 and to the left 1. Down 2 to the left. Opposite of what you were doing, down 2 to the left. And you're going to stop right there because you can't go any, or you can go 1 further, down 2 to the left. Notice that the points are in a straight pattern there. And I'm going to move it just a little bit out. And I'm just going to connect. When you get your ruler, you connect all of those points in one straight line. Notice that I do not have to swerve to hit the points. When you go ahead and connect those points, you're going to go beyond the last point off the graph and put your arrow. Beyond this last point and off the graph and put the arrow. Remember to put your equation y equals 2x minus 3 by either the top or the bottom of the graph. This way you keep it off the graph. And this asks you, is this a direct variation? No, it is not a direct variation because it does not go through the origin. And that is how you justify it. And that's how you graph that line. All right. Number 7, if you ever see a question like this, just remember you need two things to identify the equation of any line. First off, it's m, which is the slope. You need the slope, and you need that y-intercept, because remember, you have to put that equation of a line together, that y equals mx plus b. That's what you have to have. All right, so let's go ahead and get the y-intercept first, because it's the easiest thing to identify. Here's -1, -2, -3, -4. This is -5. This is the y-intercept. So we're going to put -5 down. And then we're going to take this point right here that they have for us, and we are going to change that color. This way you can see it. And I am going to draw a line to the left and also a line up. And then I'm going to count. So this is 1, 2, 3. And I'm going to put the 3 on the outside. And this is 1, 2, 3, 4. I'm going to put the 4 on the outside. So the slope is 4/3. It is a positive slope because it goes up from left to right. So this is 4/3x. Y equals 4/3x minus 5 is the equation of that line. Now we have y equals -3x plus 4 that we have to graph. Here we go. We're going to identify the slope first. And there we go. We put the 1 underneath, right? Because it's a whole number. So it's -3/1. That's the rise. The rise is going down because it's a negative, and the run is going to the right. The y-intercept is the b, which is the 4. So now I'm going to put the 4 down as a nice point, and I'm going to go down 3, 1, 2, 3, and then go to the right 1. It's very important to have the directional arrows. Just to look back, 1, 2, 3, down, and to the right 1. 1, 2, 3, to the right 1. 1, 2, 3, to the right 1. And let's see if we can go further. Yes, we can. 1, 2, 3, to the right 1. And then remember, like we did before, we're going to go 1, 2, 3, up 3, and now to the left 1, opposite. You see how the points are all in one line. 1, 2, 3, and they all are in the same pattern. I am going to connect those, taking a ruler and connecting those points all together. And you notice that I don't have to swerve to hit one of the all of those points. They're all in one pattern of down 3 to the right 1. Remember, put your arrows at the end of the line, extend the line all the way off the graph, and put that equation on the top right there, and y equals -3x plus 4. Remember, this line goes down from left to right, crosses at 4, everything looks good, and that's finished. Is this a direct variation? Same thing as the other one. No, it is not a direct variation. It does not go through 0, 0, which is the origin. And just like I said, this is not a direct variation. This linear function is not a direct variation because it does not go through the origin, which is 0, 0. Again, we're going to graph this. Remember, just put a 1 underneath. I have to put this, there's a 1 underneath. And remember, there's a -1 that's in front of it. So this is -1/1. And then the y-intercept is that other number, which is 0. So I'm going to put -1. I'm going to put my directional arrows to right next to it is down and to the right. So we have 0, 0 starting, and we're going to go down and to the right. This is a negative slope. And when you have -1 slope, it's very easy to actually plot the points, because it's down 1 to the left, to the right 1, and you know that you have a negative slope because it's going down and to the right, down from left to right. And then you continue the pattern. Instead of going down 1 and to the right, you go up 1 and to the left. And you can see that my pattern is finished just like that. And then we're going to connect those points. All of the points are in the same pattern using that same rise over run. It is a constant slope. We're going to put arrows on the ends, and we're going to put y equals -x on the top. Is this linear function a direct variation? This one is, because it crosses through 0, 0. And there you have it. Just like I said, it crosses through the origin. That is a direct variation. For number 2, you see we have to graph, but this is not in y equals mx+b format. You have to add 2 to both sides just like that. And then we're just going to go ahead and put that into y equals mx+b format. That cancels. You have y equals -2 over 3x plus 2. It doesn't matter where you put that negative. You could put the negative right next to the numerator or the denominator, but you cannot put the negative in the numerator, next to the numerator and the denominator, right? Because that would be like a negative divided by a negative. It would be a positive slope. So just remember, you have to choose. I always choose the top number of the fraction, just like that, where you're seeing it. And the y-intercept is the other number. So I'm going to go with the rise as -2, that's down, and the 3 is going to the right. So the first point on my graph is the y-intercept. That is the starting point. You're going to go down 2, and then 1, 2, 3 to the right, just like that. Down 2, 1, 2, 3 to the right, just like that. 1, 2, 1, 2, 3 to the right, and you can't go any further. Now you're going to go opposite, up 2, and then 1, 2, 3 to the left, up 2, and then 1, 2, 3 to the left, and again 1, 2, up 2, 1, 2, 3 to the left, and you can't go any further. Now you're going to take your ruler and connect those points. Notice that they are the same pattern. That means it is a constant. That means you did not make an error with the counting. Just to go ahead and extend that line off the graph like I just did. I'm going to move this a little bit off the graph and onto the points just to make sure. And I'm going to put that arrow. And I'm going to put the y equals mx+b. This is y equals -2/3 x plus 2. And yes, it does check out. It goes down from left to right and crosses at 2, the y-axis. So is this a direct variation? No, it is not, because it does not cross the origin. There you have it. That is the reason why it is not a direct variation. And number 3, probably the most difficult out of all of them. I'm going to zoom in just a little bit here to 200. Just remember, when you're solving, you have to solve for y. It's y equals mx+b. So you cannot identify the slope in the y-intercept unless it's in that format. So we're going to subtract the 4x. It's the first thing that we do. Subtract the 4x on both sides. Once you subtract the 4x on both sides, you get that to cancel. You have 8y equals, I'm going to put the -4x first, and then the plus 16. Now, the last thing that you do to get y alone is to divide by the 8. This cancels. The y comes down. You get negative 4 over 8, which is negative 1/2, reducing the fraction. And then 16 divided by 8 is 2. So that's exactly where you get it. This right here, if 4 divided by 8 is negative 1/2, and then 16 divided by 8 is 2. So I'm going to put the slope as negative 1/2, and I'm putting the negative next to the 1, and the y-intercept is 2. So that is a down because it's negative 1, and 2 because it is positive. So now we're going to go to the graph. We are ready to graph this. So the y-intercept is 2. That is my starting point. Put a nice big point. And you're going to go down 1 to the right 2. Just like my directional arrows say. Down 1 to the right 2. If you make a mistake, you'll see that the points do not fall in the same pattern. Then up 1 and to the left 2. Opposite. Up 1 to the left 2. Up 1 to the left, and then up 1 to the left, and then up 1 finally to the left. You grab your ruler and you connect those points just like that, and you put your arrows on the ends. Notice that this point right here, I just moved a little bit off, but they're fine. And then just go ahead and put the equation on that line. Y equals negative 1/2 x. And it should be negative. It goes down from left to right and it crosses 2. Is this a direct variation? No, it is not, because it is not going through 0, 0. All right. And that's basically it. And there you have it. No, this is not a direct variation. Just take a look at it. It does not go through the origin at all. That crosses it too. So this is not a direct variation. Write the equation of the line graphed on the coordinate grid. Again, you have to identify the slope and the y-intercept. I think the y-intercept is way easier. So this is the y-intercept right here. So that's a 1. So we're going to put that down as 1. I'm going to go with this point right there because it's the closer point. But you could use whatever point that you want. You could use any of the points that fall within, that have whole number coordinates. In other words, when you could see that this is negative 1, 1, 2, 3, 4. This is negative 1, 4. So you know that, I'm sorry, it's not negative 1, 4. I don't know what I'm saying. It's negative 4, negative 1. Sorry, positive 4, negative 1. Wow, it's late. So these are whole number coordinates. That's why you could use it. This one right here, this point, would be 6, negative 2. All right, 6 to the right and negative 2 down. So you know that you could use it. You know exactly what whole number coordinate it is. So you could count the rise over run. You can't count like something like this point right here. That's not a good point. Because, again, you would know 1, 2, 3, but you don't know if that's a negative 1/2. You don't know exactly what that is. So that would not be a good point, and that's the reason why you would not choose that point. So let's go ahead and make the triangle. And again, you could use this point that I was going to use. It's the same triangle that you're going to make. Again, this goes down 1, so I'm going to put a negative 1, and then this goes to the right 2, and I'm going to put a positive 2. All right, so you know this is a negative slope, so it is a negative 1, that's the rise, and over 2. That's exactly what it is. Even if you did this one right here, -1, 2. Even if you did this one, -1, 2. And they don't have to be exactly right next to each other. They could be further apart. But just remember, the further apart that they are, you run the risk of getting something, counting something wrong, or and then also that you have to reduce the fraction if it's further, the points are further apart. I did not have to reduce this because they were close together, and we're going to put this into the equation of a line. Y equals -1/2 x plus 1 is the equation of that line. You could actually put that there. -1/2 x plus 1. And that is it. It is not a direct variation. Does not go through the origin. We're just going to go to the next one. The next question. So determine the equation of the line in slope-intercept form. That's y equals mx plus b. And we're going to just do this as quick as possible. Again, -2 is the easiest thing to put down. That's the y-intercept. And then we're just going to use the points that they give you. All right, so this is 1, 2, and this is 1, 2. So if you did that, that would be incorrect. This is how tricky these graphs are. Remember, see the x-axis? They are going by 1, so this is 2. But you see the y-axis? That's going by 2. So if you counted 2, it looks like the rise over run is 2 over 2. But it's not. But so this, you see how it goes 2, and this is 0, and this is 2. So that means they're going by 2s. So you're counting 2, 4. So 4 over 2 is 2. So the slope is 2. Let me get that in a better way there, because this is 4 over 2 equals 2. So the y equals mx plus b is y equals 2x minus 2. All right, just be careful about that, because it's very easy to get it wrong. So now here we go. I'm going to pick the y-intercept as 0. That's the easiest thing. This is a direct variation. So I'm going to go ahead and create my little triangle. And I know that the x counts by 3s. So this is 3, 6. I'm going to put 6 out here. And then the y is counting by 4s. So this is 4. So that is 4 over 6. But I'm going to reduce it to 2 over 3. And you could do that just by putting it into the calculator. If you have 4 over 6, you could grab the calculator. You could just do 4 over 6, just like that. That's alpha x. You bring up the fraction symbol, just like that. Just like that. And if you press enter, it just reduces it for you, all right, to the lowest form. So it is 2 over 3. So we have y equals 2 over 3x. And you don't have to put the plus 0. All right, for the next one, number 3, we have a y-intercept of 1. And I'm going to just grab this point and just make my small triangle. This right here is a -1. It's going down 1, and it's going to the right 1. And all of the x and y coordinates are counting by 1s. So -1 over 1 is -1. So this is going to be y equals -x plus 1. This one is a y-intercept of 0. This is a direct variation. I'm going to put that dv right now. So I'm going to make my little triangle just like that. That is a -4, 4. All right, that is -4 over 4, and that's a -1. So this is y equals -x, and it is a direct variation. Goes through the origin. Number 5, again, another direct variation. So I'm going to put dv. And this is y-intercept of 0. So I'm going to create my rise over run just like that. And we're going to go to the right 1. That's my run. And then up 3 and 6. So the slope is 6 over 1, which is equal to 6. So the y equals mx plus b is y equals 6x. And I forgot to put the equation of each of the lines. This is y equals negative x. This one is y equals negative x plus 1. And then we're going to switch to another color. And this is y equals 2x minus 2. And this is y equals 2 over 3x. All right, last one here on this page. Again, another direct variation. I think that's the third one in a row. We're going to do our rise over run, and we know this is direct variation. The y-intercept is 0. So the run is 4. It's going by 2's the x-axis, and this is going by 1's. So this is 2. So this is 2 over 4, and you know 2 over 4 reduces to 1/2. So this is y equals 1/2 x. And since it's a direct variation, that's the way it stays. That's the way you're going to label that line. Y equals 1/2 x. Let me put the x right next to the fraction. Just like that. Okay, so this is the last page here. So it says write the equation of the line with the coordinates shown in the table below. And this is a very, very important thing. You have to put it in slope-intercept form. So you need the slope and the y-intercept. Calculate both. You know that I think that the y-intercept is the easiest thing to identify. So if you're just looking at this, I'm just going to highlight for you this. Okay, that went away. So when the x is 0, when the x is 0, this number is the y-intercept. When the x is 0, the other number is the y-intercept, just -4. And if you think about it, just like if you sketch it, like just a small sketch just like this, right? So if this is the y-axis, this is the x-axis, right here, 0, -4 would be right here. You notice how that is the y-intercept. That's where it crosses the y. The line crosses the y right there. If the x is 0, it's along the y-axis. The point is along the y-axis. So wherever x is 0, the other number is the y-intercept. So now we're going to get the slope. And I'm just going to tell you, the easiest way to do this is to do it with positive numbers. You could label anything x1 and y1, any two points. I'm going to label all of the positive points x1, y1, x2, y2. So that means I'm going to put this as y2 minus y1 over x2 minus x1. And I'm going to do m equals, I'm going to put my minus signs in, and you see y2 is now positive, that's 2. y1 is 0, nice and easy. Look, x2 is 3, and x1 is 2. And again, even though I have really simple numbers there, I'm still going to use my calculator. I'm going to do alpha x, and I'm going to put 2 minus 0 in the top part of my fraction, and I'm going to put 3 minus 2 in the bottom part of the fraction. And then, so when you get that into your calculator, you press enter, you get 2. All right, so m equals 2. And then the linear equation is y equals 2x minus 4. Y equals mx plus b. So you have your y-intercept right off the bat because the x is 0. Nice, they gave it to you. And there is your slope. If you forget that when the x is 0, the other number is the y-intercept, just take a piece of graph paper, plot all these points, and you'll see exactly where the line crosses the y-axis. All right, that's another trick that you could do if you get stuck. So number 2 is exactly what we've been doing. Go ahead. This is now -3. That is -3. This is -1, -2. The numbers are off a little bit, so the y-intercept is -3. We are going to take this right here and then make our triangle down. So it's -1, -2, -3. -3 because it goes down from left to right, and then it goes right is 1. So it is -3 over 1. That's down and to the right, just like that. Not that you needed that because you're not graphing, but it is a -3 slope. So y equals -3x minus 3 is the equation of the line. Y equals -3x minus 3. Line goes down from left to right, and it will have a slope of -3. Pretty steep. All right, so here we go. We need the slope and the y-intercept. Just remember what I said before. When the x is 0, the other number is the y-intercept. So in this case, it is 0, 3. Now all you have to do is calculate the slope. I could use whatever numbers I want. I'm going to do x1, y1, x2, y2. So I'm just going to put the slope down as m equals y2 minus y1 over x2 minus x1. M equals, I don't know what kind of line that is there. That's pretty bad. Let me put that back. M equals. It's a little bit better. So y2 is the 7. y1 is 3. x2 is 1. x1 is 0. Grab the calculator and then press alpha x. 7 minus 3. 7 minus 3. And then 1 minus 0. And just like that, you have 4 as your answer. So the m is 4. Slope is 4. And the y equals 4x plus 3. And that is it right there. That is a 4, even though it looks weird. And that's it. All right, so that's basically all of what we learned about graphing and using the y-intercept and the slope to graph or identify the equation of that line. Hopefully all of this practice definitely helped you. The only difference between Algebra 1 and, there are two differences between Algebra 1 and 8th grade math. Number one, the 8th grade graphs, they do have numbers on the graphs, just like you see here. And you see here, like the numbers are on the graph. The Algebra 1, the 9th grade, the numbers are not there. Also, but a big thing about the 9th grade is that you have the graphing calculator. You're allowed that graphing calculator. In the 8th grade, you do have only, you do not have that graphing calculator, and you have that scientific calculator. All right, a big difference. But this is all 8th grade practice, so the numbers are on the graphs just like that. You're doing everything by hand. Just remember with the directional arrows, like I said, every time you put the slope, when you identify the slope and you're graphing, you do it in rise over run format. Make sure that you are using those directional arrows on the sides. This way, when your eyes are shifting back and forth, you could look to see what your arrow, and that for the numerator is going down because it's negative, and then it's going to the right. You're not going to make a mistake because you're looking back and forth and you're trying to plot and at the same time looking at your slope. All right, and that's basically it. All right, thank you for watching. Hopefully this video helped. See you next time.